Welcome everyone to this session number 302 afternoon, and well, today I will try to resolve. I checked this before, but sounds like it's more a mathematical problem. Yeah, and today I don't I don't want a fight with these kind of problems. Okay, algorithms. Let me check. Monotonic stack. Maybe it's a good day to try again with the monotonic stacks. A little bit to remember this topic. Basically, the monotonic stack have a tendency increasing or decreasing or keep the order. This is the pseudocode here. Yeah. And while the stack length is equal, well, it's not empty, and the stack pop it's greater equal to the num. Well, in this case is basically this. Yeah. Now let me move to the code problems. Where is my okay? And our aim stacks is monotonic stack. Let me check this. Okay, this is the pro. Okay. This is the problem 1130. Minimum goes 3 from the leaf values. This is the problem of today. Yeah, and say given an array of the positive integers, consider all a binary trees such that each node has either 0 or 2 children. Okay, the value of array correspond to the values of each leaf in order transversal of the tree. Okay, the value of each leaf node is equal to the product of the largest leaf value in its left and right subtree respectively. Yeah. Among all possible binary tree consider return the smallest possible sum of the values of each leaf node. It is warranted sum fits into a 32-bit integer. Okay, a node is a leaf if and only if it has 0 children. Okay, and we have this okay. Okay, in this case, for example, the 4 don't have any children. Yeah, we have this array 6, 2, 2 and 4. That means that this and the 4, uh, the value of every node. Mm, mm, 32. 24 plus this. No. I don't catch. What is the proposal that is? Okay, let me come back this. For example, in this case, among all possible binary tree, consider return the smallest possible sum of the values of each no-leaf node. In this case, for example, is 12. That is not a leaf. 24. Mm, 24 plus 8, 32. Each node has I don't understand the question. Constraints, array it's at least 2 and the max is 40 and the values are between 1 and 15. Is warranty answer? Okay, it's an integer and oh my gosh, it's acceptance rate. It's is this mm, 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 mm. I need return an integer, but okay, I understand that we need create the this binary tree where the sum of this node, for example, return the small possible guarantee. Return the smallest possible sum of the values of each leaf node is guaranteed. The value of each node is equal to the product of the largest value. Okay, I need to create the tree considerative rule. Well, let me check the comments. My gosh, it's monotonic stack, but at the same time, I think that it's dynamic programming. Yeah, it's a little complicated because the first point is complex to understand, but the next two is I understand that it's necessary to create the binary tree having this rule. Yeah, and next to we need to return the small possible sum of the each value here. Don't count this value. And this for example is a leaf, is not count, is not count, is not count, is only this, and for the reason appear 32. Now it's too much complex. Let me check and use. Always the problems related with the monotonic stack for me, I feel as a hard. Let me check. Shortest override. Find the most competitive subsequence. Carflet 2. I remember the one. Maximum score, the sub-array. No, only mediums. I don't feel comfort trying with the hard. Jump game 4. Sum sub-array range. Maximum length of the semi-decreasing sub-arrays. Remove n from the linked list. Okay, let me sort it for the accepted criteria. Yeah, resolve this. Maximum array, I hope. Dynamic programming. Yeah, I think this is not the problem of today. Huh? No. Okay. Okay, let me check the topics for avoid. Sorry. And the final was this is the real problem, and is remove node from the linked list. You're given a head of the linked list, remove every node which has a node with a greater value anywhere to the right side of it. Well, basically it's a monotonic stack because you have 5, 2. Okay, let me copy this. I have too much time that I don't resolve problems with the monotonic stack. Okay, and say that remove every node which has a node with a greater value anywhere to the right side of it. Okay. Switch, where is switch? Ah, here. Okay. Mm. Yeah, basically it's this. Mhm. And we have a linked list. Yeah. Uh, the first time we have 5. Next to is the 2. Until this moment it's okay. Next to is this. Basically remove this and only keep this. Next to remove every node which has not no here we have every node which has a node with a greater value. In this case is this. Yeah, the first number is this because we have this number. Next to is the 2 because we have this number. Next to is this. mm, we don't have more number here. This next to is this because we have the 8. And okay, the number of the nodes is a given list in the range between 1 and this. Okay. Mm. Oh, okay. Yeah, I understood in a wrong way. What is leetcode? Leetcode, Twitch. Okay. Now the first is that we have 5 and we have any greater value here. Yeah, because we have this. Okay, remove it. 2, we have any greater value here. Yeah, is this. Okay, next to is this. We have any greater value here. No. The next stat is the 3. We have any greater value here to the right. Yeah, because we have the 8. And next to is the this because basically we don't have more elements. And what I need to return is this. Okay, the first way that I have in my mind to resolve it is basically for each and only have these numbers. Yeah, have a monotonic stack where appear. Okay, 5, 2. Okay, this is remove it. No, 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 no. It's 5, 2. Okay, next to is in decrease order. Now is this to remove this element. Now is the 3. Now the 8 is remove it, and the final is this. In this way we have this and this, and we can for each again these values, or only create this node and create a reference to the next, to the next, to the next, to the next. Yeah, and return this. Now this is my first approach. The next two, I'm not sure that if it's possible to do with two loops, without two loops. Basically, I can start here and say that, okay, this is my node, and it's here because we don't have more elements to the right. Got it? Now the next is the number 3 is minor, is ignore. Okay, move to the next. This is minor to the current value, that is 8, no. Next to this is minor to this, no. This is minor to, this is minor to this, is ignore. This is minor to this, yeah. But here I need return the head of the modified linked list. Yeah, here basically is, we are here. I am trying to resolve without use two loops. We start here. For the foul is, okay, this is a head, it's equal 8, yeah. Now let me check if I don't have any constraints about, no. Okay, next to is that is we should use a monotonic stack for keep the increased order. In this case, for example, is the number 3. 3 is ignored because it's not here. The next is this number means that ahead, no, this is temp, it's equal 8, yeah. Head, it's equal 13, and 13 could reference to this, and this to the right is basically all the time is null. And move to the next, okay. Okay, now again, we have a head, no, but I am doing this this problem starting here, but for this I need to change the order of the elements. No. Yeah, because the only way to transversal this single linked list is in this way, no in the positive way. No, it's possible resolving this. For example, have a head, it's equal 5. Okay. Now move to the next. The next is minor, means that we can ignore. The next is this number 30. 30 is greater than, no. In this case, we start with the 5 here. Okay. The next is minor. Okay. The next, the next is this 13. This is greater, means that we need to remove this, and we need to remove this. And if we don't have more elements, do you imagine that we have, for example, 15? Should remove until this point, and this reference to this number. Yeah. This case is the only one this. Next to is the 3. Okay, next to is the 8. The 8 remove this, and this is connected with this, and that's it. Now for this I need to use a variable named root, no. What is the name of this head? Result. Yeah, result it's equal to the first element. In this case is a head. Yeah, and we start with yeah, with a while head it's different to null. Yeah, basically move, and in this case t it's equal ahead. Uh-huh. And here is basically have but how can I remove, for example, if I have 5 and 2 and appear this, I can I only have this reference, but how can I remove until this point? For example, if we have more elements, how can I have this reference this? Mm, yeah, no. The problem is this reference. Uh, got it. I know how to access to the this reference. Basically, having a hash map, yeah, where appear the value. I think that the value are different. Or let me check, because of the this depend of the this test, and here return ahead. Let me check if no. Mm-mm. I am trying to use monotonic map for, say, for example, 5 this is the reference, 2 this is the reference, uh, 13 this is the reference, whatever. But if it's possible have duplicates, I don't have more solution that use two loops. The first loop is for discover what is the elements that are in the result, and next two is another for each. For no, even I don't need for each this is for each this result, and create the node and create the next node, and that's it. Yeah, I was trying to resolve with two loops, but I think that I don't have more ideas how resolve without use two loops. Well, the first that is stack. And stack, name it stack. Here's an stack of the integer. It's equal new. Sorry, new. No, even here I can use. What is the other structure? Is stack, and the other is it's not queue. Or yeah, even we can use a queue. Here is a queue. It's equal new linked list. Yeah, and this is important because when we have the result, we should start here and move to the next, to the next, to the next, and not starting with the last element. Yeah, basically it's the fifth in, first out. Okay, next two is that to do this operation is while head it's different to null, is get the value here, integer n, it's equal head dot val, yeah, and here is while stack is empty, is not empty, and stack dot peak, we should create a decrease order, means that when the last element or the element in the top, is a queue operations in Java. Yeah, it's this. This peak is the same. Stack, and it's not a stack, it's queue. Yeah. In the peak is it's minor equal, because could have no minor to n, we need remove q dot poll return, removes and return the element and the front, yeah, is poll, yeah, and basically move on the final. Here is q dot add n, and head, it's equal head dot next, yeah. With this I know what is the result, and next to basically is only a while, yeah. Here, okay, we need create here list node, result, it's equal new list node, no, it's equal new null, and no, here it's equal new list node less one as a value, yeah, and here is list temp, it's equal result temp, it's equal result, and here is basically q is empty, no, it's different to null, and or is empty, but negative. Basically here is temp dot next, it's equal to new list node, yeah, and here is the value, here is q dot pull, no, here is not pull, is from the queue, front of the queue, no, I need remove the last, remove return the element at the front of the queue, offer, yeah, is this offer, no, let me check here, remove the front, should be, oh, it's here, okay, apple, banana, q, first. No, I need to remove the last. No, this is not the structure that I need. What is the other? Um, Q stack n. DQ. Yeah, I think this. Yeah, this is the structure that I was trying to use. This is the DQ. It's here integer, and the operation of the DQ are DQ Java operations. Okay, it's here. DQ. DQ at first, at last. Okay, yeah. In this case, is basically pick last. Let me check. Pick last. In this case, is pick last. Here is this. Okay, pick last. In this point, I need use this DQ as an stack. Means that is pick last, pull last. No, even remove last. Oh no, this pull last is empty. I think that is the same. It's empty. Well, don't appear, but I'm sure that exists. Pull last and add last. At last. Okay. And now for this is the positive. Pull first. Yeah, create this. And here is Q. It's equal Q dot next. And is here result dot next at last what? And this is not the queue is empty. No, this is not necessary. Okay. For this, okay, pick last, it's minor. To this, I need remove at last. Yeah, until this moment, I should have the right DQ. Yeah, DQ. Temp.next. Even if I have here temp, I am using wrong the reference here. It's think that it's only necessary this temp it's equal temp dot next for move to the next, to the next, to the next, because another way is replacing, yeah. Yeah, I think that is with this, and okay, we can try with another test. Okay. Can you execute? Okay, everything looks good. Let me zoom it. Okay, let me, oh my god, here, remove this solution using the queue Java. Okay, this is the problem. This is our solution, and okay, now let me check if, let me think another way to resolve it without using a double loop. Yeah. Um, mm, okay. Let me check the structure of the this. Only we have next. Okay. Is delete this. Yeah, maybe saving the reference. The problem here is saving the reference, but oh, come on. Here. We have a hash map. And this hash map, well, I think that don't use the number as a key here. Use the object, for example, 5. Do you imagine that we have another 8 here? Yeah, we are saving the reference. And what is the next? For example, the 5, the next is 2. The 2, the next is this. The 13. The 13, the next is 3. You know? And what is the reason of this? Basically, for example, have a monotonic stack. Yeah, the same. And the queue and blah blah blah. And the first is 5. Okay. And we can map in this here. Before to add is mapping 5, and the next is 2 because we have the next. Yeah. Okay. This is keep in the same we don't need execute the while that help us to do the monotonic stack. Okay, move to the next is 2. Should we decrease this structure? Okay, the 2, and here is the 2, and the reference for this. Don't execute this. Now the next that is this, the 13. 13 is greater than 2. Okay, this is remove it, and this is remove it, and only keep this 13. Obviously this 13 is the reference is 3. Next to is the 3. Yeah, here. Okay, don't execute nothing, but we should add here. Now the next that is 8. This 8 is greater than this, yeah, means that this is removed and only have this. And here in this monotonic stack I can save, no, even it's not necessary, yeah, no, yeah. In this, for example, we have the thing, it's here is an integers, yeah, here is the 3, next to is the 8, and we have this mapping, yeah, for say that the, well, the 5 is to the 2 is, sorry, 13 is, the next is 3, the next is 8, yeah. In this case, for example, the 8 should remove this, okay, and only have it this way, and next to is only for each this, and for example 13 and is, okay, let me, I need to, no, even it's not necessary this, I need to, no, but it's the same. I was thinking to, save the reference of the object, for don't create the new node, but it's exactly the same. Don't change anything. No, my first or my previous idea is, okay, we have 5 is connected with the 2, okay, next to is the 13. I know that the last is this, is removed, the last is this, is removed, and only keep the 13. Next to is the 3, yeah, got it. Yeah, I think that is possible only with one, because yeah, we can use an map, but save the reference, not the number, and here is the, what is the next, yeah, because for example the 5, okay, the 5 is here, and the next is 2, and basically we have this, we are here, right, and okay, it's, the last element in this list is the 5, okay, move to the next is the 2, yeah, we are following the same, this is the same structure, okay, it's minor, keep it the same, yeah. Now move with the next, that is 13. In this case 13, this value is greater than the previous, yeah. We can save here in an integer, no, in a node, for example, and search here, yeah. We know the last is 2 is minor to 13, we need remove it, and for remove it we need search here what is the number that is before this 2, no, what is the number that is before, yeah, maybe here I can save, no, yeah, what is the number that is before number and before, yeah, or what is the origin. In this case, for example, the number is 5 and before the 5 is null. Move to the next is 2, and this is the reference of the before. Next to is this, and before is 2, yeah. With this way we can do, for example, 5, okay, is the first element, and the last is null, Yeah, in this case, for example, when is different to null, um, and the value it's minor to the previous, but in this case don't apply. Okay, continue. Okay, now the next is the 2. Okay, the 2 is minor to the last, and obviously we should have or handle this reference. The last is 5. um, 2 is minor to 5. Yeah, we don't need disconnect anything. Okay, and until this moment don't have any update here. Now the next is 13. Yeah, we are here in this moment. Okay, in this moment this is greater than the last. We need to, the last in this moment is 2. Basically is okay. The number 2 the father is 5, remove it, and now the last element is 5. 5 is minor to, this is minor to 5, no. Okay, the previous is null, and basically disconnect. Another way to do is with the same idea, but having a monotonic stack. Well, with a stack that, for example, the first element is 5. Okay, move to the next, well, the 5 is here, and having this reference. Okay, now the next that is 2. 2 is minor. Okay, don't execute nothing. The next is this, and we need ask this is minor to this. No. Okay, we need to remove this reference, means that, okay, what is the number? The number is 5. Here, remove. Yeah, now the next that is 5. It's 13 is minor to 5. No, we need to remove it too, and the final is only this. Yeah, okay, now we move to the next is 3. The next is the 3. Okay, the 3, it's okay, and we need to move to the 3. Next to is the 8. 8 should remove the 3. The 3, the father is 13. We need to remove this, and it's only connect this with this. Okay, let me check the stacks. Yeah, this is the first idea. Recursion, I bet that is the same. Well, both are linear, reverse. Yeah, this was another idea to me, that reverse the linear. Okay, the queue currently is different to null. The queue is empty, equals val. Okay, I will check the solution tomorrow. No, but it's with 2 whiles. No, yeah, because this is the, yeah, I will check tomorrow.